Okay, so we're going to look at characteristics of quadratics. We're going to go through a couple examples and look at some new notes. The first one asks us to describe the quadratic parent function and how it's transformed to obtain the graph that you see to the left. Now, if you don't recall, the parent function is y equals x squared, which looks like this. Okay, so the new one has been moved down, so we're going to write down just moved down. You want to go ahead and put 5 units, that's fine. The new vertex is at 0, -5. The axis of symmetry for the new one is x equals 0, which happens to be the same, that hasn't changed. The domain has not changed, it's all real numbers. But the range has changed. Now the range is going to be y is greater than or equal to -5 because it's right here and going everything above it. So it's greater than or equal to -5. Now, what I want you to do is try the second one. What I prefer you do is go ahead and pause the video now and then try it and then come back and check it. So go ahead and pause it now and come back in just a minute. All right. Now I know some of you just sat through 2 seconds of silence. You're going to copy down what I do. Others of you have gone ahead and tried to work it out. Now you're going to see it. The first thing you should notice, this parabola has been flipped. And if you remember, the reason it's flipped is because the equation, which we're not going to write down here right now, but the equation now has a lead coefficient of a negative, like -x squared instead of x squared. That's going to cause the parabola to flip over the way it does. The new vertex here is now 0, 5. The axis of symmetry is, as always, x equals 0, because that hasn't changed. It hasn't shifted left or right. The domain is all real numbers, because that part hasn't changed, but the range has. The range is now y is less than or equal to 5, because it's opening down. Okay, as we go through the second page, feel free to pause at any time to write or kind of get an explanation from somebody you're sitting with, or just continue writing and copying and listening. What we have to the right here is a parabola, but we don't have the entire parabola. But remember, we talked about this being symmetrical, and you can see there is a axis of symmetry right there. It means it's symmetrical on both sides of that. Now, we can still answer questions about this parabola. The first one says what is the domain, basically, and of course that is always all real numbers. The range, we can see the lowest point down there at -9, so the range is going to be y is greater than or equal to -9. That won't change. But now we can see the vertex. The vertex is -2, -9. And that represents a word that we may or may not have spoken about too much, but we did talk about this at the beginning of the year. That is the absolute minimum. Remember, a parabola that opens up like that has an absolute minimum. Okay, now the axis of symmetry, well, we can get that from this first number. So the axis of symmetry is going to be x equals -2. Remember what happens if you don't write x equals. If all you write is -2, this will be counted incorrect. Now, if you know the axis of symmetry, that means that you can determine more points. To extend the graph, because right now you only have half the graph, but you can continue extending it. And it's pretty simple to do. Okay, you have your vertex right here at this point. Okay, your axis symmetry. Look at this line. All right, these 2 points are equidistant apart. So you can see, look for points where they match, like right here at 8 and right here at 5. Okay, at this point, you are 2 units away from the axis of symmetry, so go 2 units over here, and you've got this point. Up here at the x-axis, you have this point, which is now 3 units away, so go 3 units this way to right here. You can go all the way up to x equals 2, and you can see another point that's now 1, 2, 3, 4 units away. So go 4 units that direction, and you've got another point. Okay, so by doing this, you now have a way to draw the rest of your line. Okay, it's not perfect, but it's a pretty good drawing, and it is symmetrical to what you're trying to do. Now we can continue looking at the next part. Okay, and answer these questions. The x-intercepts, oh, I'm sorry, forgot to finish at the bottom. The y-intercept of the graph is the point 0, -5. You can see that point right here. All right, so finishing out the next section, the x-intercepts of the graph are the points 1, 0, and -5, 0. The zeros of the function are 1, 0, and -5, 0. The roots are 1 and -5. And the last section says the x-intercepts, zeros of a function, and roots of an equation are related because they are the same point on a graph. These sections over here, we're not going to do right now. We're going to do those later. Okay, as well as the bottom sections. We're going to skip that for now. Okay, so this next section is a series of graphs with some statements or questions. Basically, it's just true, false. So look through it, and if you see something that's false, or the underlined part is false, go ahead and correct it. Okay, we'll do the first one together, then like before, I'll pause it and give you a chance to go do it on your own. Okay. The graph on A, you can see it's partial. It's a partial parabola, but it's going to continue going. And, you know, like we did earlier, you could draw some other points. But we'll go ahead and answer questions. First of all, the graph passes through the origin. And as you can see right there, it does. So that is true. Let's enlarge that a little bit. Next, the second one, the vertex lies on the x-axis. Well, remember, that's the vertex. And that's the x-axis, so that is a false. The vertex lies at the point -2, +4. Next, there's an axis of symmetry at x equals -4. X equals -4 would be right here, so that is also false. The axis of symmetry is right here at x equals -2. And finally, the graph has a 0 at the point -4, 0, which is right there. If you were to continue this graph along, it would look like that. So that is a true. At this point, go ahead and pause it. And then I want you to work through B, C, D, and E. In fact, yeah, and for E and F, as you're going to go all the way through F, for E and F, you're going to want to use a calculator. Go ahead and put that equation in the calculator and check it. Or use that information instead of, you don't have a graph for it or you don't have a picture of it here, but go ahead and use the table from the calculator. And then after you do that, go ahead and come back and check it, and the answers will be here and with a brief explanation. All right, hopefully you've gone ahead and worked these out, but if not, you can check them. For part B, all 4 parts are true. If you were to put those points into the graph and then check them, this would have a range of, it would look like this if you drew it. It would look like this, which means all of the values are going up, or it's opening up, which means A is greater than 0. You can see the y-intercept is 6. What you can't not see on the third one is that the 0, meaning for f of x, the 0 is going to be right in here, which is between -3 and -2, so that part's true. That's where you'd find that value. And then finally, the vertex lies on the x-axis. If you look carefully through all of this, you will see that the vertex is right, here we go, at 0, 6, and that will be on, that will not be on the x-axis. 0, 6 will be up. Nope, let's try that again. That's not the vertex. Don't know what I was thinking there. Must be too late at night for me to be doing this, but the vertex is sorry, at 0, 6, but that is not on the x-axis. Okay, so that is a false. It is on the y-axis. Yeah, eventually you get that right. And then we look at the bottom. The first one, the graph of the function contains a 0.63. It does not. If you take a look at this and follow it up, you've got a point here, here, you've got this point, which will be right there. So that means it goes up, and that point is 6,4. So the point is not at 6,3, the point is at 6,4. Next, the vertex lies on the x-axis. That part is true, because there it is. Next, there's a maximum value of the function at the vertex. That is not true, it is a minimum. And finally, there's a 0 of the function at 4, 0. That is true, it is also the vertex. Now looking at the last page, part D. First statement says the graph passes through the origin, and you can see that right here that it goes through the origin. So that's true. The second one says the vertex lies on the x-axis. The vertex is right here at 2, -4, and that is not on the x-axis. So it's false. The next one, there's an axis of symmetry of x equals -2, and that's going to be true because the vertex is at -2, -4, and the x value of the vertex is also the axis of symmetry. And finally, the graph has an x-intercept at the point -4, 0, and that is one of them, as you can see right there. Part E, again, hopefully you put this in the calculator so you can see all the points. If you were to look at the graph, it's basically going to look like this. Down here is -16. Okay, terrible picture, I know. There's a minimum value of the function at the vertex. That is true, because that is a minimum. There's an axis of symmetry at x equals -2. That is false. It's going to be x equals 0. The next one, the roots of the related equation are x equals -4 and x equals 4. And you will see that if you look at the graph or you look at the table. You've got those two ordered pairs. And there is a y-intercept of 0, -16, and that is true, as you can see there. And then the last one, again, put this in the calculator. This one, even if you graphed it, you'd probably have a hard time with it. It's going to look like this. It's actually much wider than the others. Okay, the vertex passes through the origin. That's true. There's an axis of symmetry at x equals 0. That's true. There's a y-intercept at 0, 0. That is true. And then the last one, the graph is vertically stretched by a factor of 1/4. That is true, but we haven't talked about that particular characteristic or use those words yet, so you can actually skip that one, and I'm okay with that. All right, so that takes care of everything. Make sure you pick up the worksheets and complete everything before next class.